Have you ever stopped to think about how something like your life insurance premium gets calculated? Or how a government can possibly know how much money it needs for pensions decades from now? It's like they're trying to predict the most unpredictable thing there is, when any one of us might die. It seems totally impossible, right? But it's a calculation that, believe it or not, our entire financial world absolutely depends on.
So how on earth do they do it? How can they put a number on something that feels so profoundly personal and, let's be honest, so completely random? And this isn't just some dusty academic question. No way. This is a high-stakes game that sets the price of your insurance, determines if your retirement fund will last, and even affects the health of entire national economies.
Well, the answer lies in this really remarkable tool. It's actually over 300 years old, but it's more powerful today than it has ever been. It's not a crystal ball, not at all. It's a surprisingly simple, kind of elegant table. And its genius is that it doesn't try to tell your individual story. It tells the story of an entire generation. So, let's meet the hero of our story, the life table.
At its heart, a life table is just a way to calculate the odds, the probability of survival and the probability of death. And the key, the thing that gives it all its power, is that its entries depend on just one single thing: age. That's it. It cuts through all the chaos of individual lives to find this clear, predictable pattern in how a whole population lives and dies. Okay, so let's get into how you actually build one of these things. It might sound super complex, but it really boils down to 4 main steps. First, you just observe reality. You count the number of people and the number of deaths at every single age. Simple. Second, you turn those raw counts into probabilities. Easy enough. Third, and this is the really clever part, you imagine a hypothetical group of, say, 100,000 babies, and you walk them through life using the probabilities you just calculated. And finally, you just average out how long that group lived, and boom, that's your life expectancy.
And when you do this really distinct pattern starts to emerge across a person's lifetime. You can see that journey right here in this table. Mortality is actually pretty high right after birth, due to congenital issues. Then it drops way down during childhood. It starts to creep back up in adolescence and then climbs steadily through middle age as diseases set in, before rising really sharply in old age as our bodies, just lose their robustness.
And if you plot that journey on a graph, it looks a lot like this classic J-shaped curve. The risk is high at the start, it drops, and then it climbs almost exponentially. But what's really interesting here is something this graph shows that the table only hints at. See that little bump in the late teens and early 20s? Actuaries have a great name for that. They call it the accident hump. It's this temporary spike in mortality caused by, more active lifestyles, car accidents, and, general risk-taking behavior before life settles down again.
Now, understanding these patterns is absolutely critical, because just looking at surface-level numbers can be incredibly misleading. So let's explore this with a classic little puzzle, a tale of 2 towns.
Okay, on the screen, we've got data for 2 fictional towns, Youngsville and Oldsville. They both have the same population, 100,000 people. You can see the population breakdown by age, the number of deaths in each age group, and the death rate. Just take a second to let your eyes wander over the numbers.
All right, so here's the question for you. Looking at this data, which town seems like the healthier, safer place to live? Is it Youngsville, where 400 people died, or is it Oldsville, where 600 people died? The initial answer seems pretty obvious, but this data is holding a little surprise.
And here is the paradox. If you look closely, line by line, the death rate in Youngsville is actually higher at every single age group. A 20-year-old in Youngsville has double the death rate of a 20-year-old in Oldsville. So how on earth is it possible that Oldsville's overall death rate is so much higher? It makes no sense, right?
The solution to this whole puzzle, it's all about the age structure. As this quote explains, the names of the towns kind of give it away. Oldsville has a much larger population of older people. And since older people just naturally have a higher mortality rate, they contribute way more deaths to the town's total. That skews the overall crude death rate way up and makes the town look less healthy than it actually is for any given age.
So the way that actuaries and statisticians fix this problem is with a technique called standardization. It's basically a way of adjusting the data to make a fair apples-to-apples comparison. It asks the question, what would the death rates look like if both of these towns have the exact same age profile? And it's just a brilliant illustration of why you can never just compare raw numbers between different groups.
Now, this isn't just a statistical brain teaser. This whole process of using life tables and standardizing data has a massive, tangible impact on all of our lives, especially when it comes to our finances.
Seriously, these life tables are the bedrock of the entire financial planning industry. They're used for everything: pricing life insurance, making sure pension plans have enough money, assessing the risk of people living longer than we thought, planning for huge government programs like Social Security, and even in healthcare for analyzing patient survival rates. Let's just take life insurance. When you go get a quote, that company isn't just taking a wild guess. Nope. They are literally looking at a life table, finding your age, and pulling the precise probability that a person just like you won't survive the next year. That probability is the absolute core of how much you pay. Or think about pensions. For a pension fund to promise you an income for the rest of your life, it has to have a very, very good estimate of how long the rest of your life is actually going to be. They use these life tables to project all those future payments to make sure that the money will be there for you and for everyone else in the plan.
And the same logic just scales up to the national level. Governments rely so heavily on life tables to forecast the future costs of Social Security and other public pension systems. And as our life expectancy changes, these tables get updated, which can then lead to major policy changes around things like the retirement age and benefits.
But of course, mortality isn't just about age. Life is way more complicated than that. Modern life tables are incredibly sophisticated, and they account for so many other factors that shape how long we live. So let's move to our final section and see how all of this builds.
You know, it's definitely not just about your age. Modern actuaries dig so much deeper, looking at a whole range of factors to create a much more accurate picture of risk. I mean, everything from your job and your diet to where you live, your education level, and even your genetics, it all plays a role.
You know, take education, for example. It's an incredibly powerful proxy because it often connects to so many other factors that shape our lives. Higher education often leads to a higher income, better nutrition, more time to exercise, a greater awareness of healthy habits, and all of those things together work to lower mortality rates.
This whole process of using all these different factors to divide people into more and more similar groups is called selection. The goal is to create these risk pools where everyone in that group is as similar as possible. I mean, a group of non-smoking doctors is going to have a very different and much more predictable mortality experience than the general population, right?
So, from a simple table that just tracks a generation's story, we've now developed these incredibly sophisticated tools to predict our collective future. We know with more and more certainty that we are all living longer. And that leaves us with one final and really crucial question. Now that we can predict this future, are our financial systems, our healthcare, and our societies as a whole truly prepared for what it actually means to live in it?